Good morning for me, good afternoon for some of you. My name is Cade Nelson. I am a systems integration engineer with Apposite. I'm sure some of you are familiar with us, but I'm going to do the kind of 10-cent tour of Apposite Technologies. We are Apposite Technologies. We're the market leader in network emulators. Not only do we have physical appliances, but we also have cloud appliances and virtual machines. We are almost 15 years old. We're creeping up on our 15th birthday, and we have over 3,000 customers worldwide. And over here is a list of some of the customers in two different verticals. So a lot of people, when they come and visit us at trade shows and stuff, kind of ask us, what do you do? How do you help us? And, we are a network emulator. We can replicate any kind of production network you can run into, whether it's satellite, SD-WAN, creating a Internet of Things environment, network storage, video streaming, cloud migration, Wi-Fi, you name it, we can do it. So we can replicate those different networks. You can test your applications over these different networks. You can measure performance and capacity. And then you can also isolate any design flaws or performance bottlenecks that could be in your existing network. So this webinar is about Netropy 4.0, the things that we've added or the changes in Netropy 4.0 is we have a new user interface that's written in HTML5. We are moving away from Flash. We have what we call the Topology View. This is a new way to visualize your paths and packet classifiers. Your packet classifiers are now relabeled as endpoints, and you can actually see them connected to your paths, so it's easier to see what's going on your emulator without having to click in and look in other areas to figure out how it's set up. We've also added some preset networks, so if you want to do certain Wi-Fi's or satellites or cellular type networks, we have quick presets that you can simply use to deploy these networks very quickly. I will demonstrate that shortly. And then we have a fully integrated RESTful API. This allows you to do any function that the Netropy is capable of doing. You can now automate that function. Okay, I'm going to quickly jump into a demo here. This is our new 4.0 interface. As I said earlier, it is HTML5. And if you're familiar with our other Netropys, you know this is an N61 model. So this is a single engine model. That means we only have 2 data ports. Any data that flows into port 1 comes out of port 2. And any data that flows into port 2 comes out port 1. So here we have the indicators showing that the ports are up. We have our emulation on-off toggle. There's a detailed statistics view and endpoint rules. And then what's most important to people here is how to add paths and endpoints. So to add a path, it's really simple. I hit the plus button here. And let's say I want to use one of my presets for Wi-Fi. I'm just going to call this Wi-Fi, and I'll drop down here and I'll have all these different presets available for Wi-Fi. So I have Wi-Fi good, bad, 802.11a, b, g, n, and a and c. So I can kind of choose any one of these. We'll do 802.11b. And as we see, it gives me 5.5 megabits up, 5.5 megabits down with 50 milliseconds of latency. So I'll go ahead and create that path. And I can see here that that path is now created. And maybe I want to create some other paths. So I'll go ahead. Maybe I'll want to go ahead and do something on my own. Maybe I want to have a connection that's going to emulate, we'll say, New York to London. Maybe it's only a 50 megabit line in one direction and 30 megabits in the opposite direction. And we have a delay of, we'll have a jitter delay of anywhere between 30 and 60 with packet reordering, 30 and 60 with packet reordering. So this gives me a round trip time of anywhere between 60 and 120 milliseconds. And I will just call this. As you see, I can come in here and change all my other types of impairments, be it background utilization, queue limit, queue strategy, jumbo framing, frame overhead. We have many different types of delay algorithms, loss algorithms. We'll add a little bit of loss in here just for fun. I'll say we're going to drop 1 out of 1,000 packets only in one direction. And then we have network outage, corruption, which is checksum errors, packet reordering, and packet duplication. I'll go ahead and create that path. And then just for fun, I'll add one more path. Let's see, what should we do? Let's just do SD-WAN. Create that. So now we have 3 networks: Wi-Fi, New York City to London, and SD-WAN test. And we can see SD-WAN test is 400 megabits with anywhere between 50 and 60 milliseconds. So now, before on Netropy 3.0, you would go in and you'd configure packet classifiers. So what we do now instead is called endpoints. I'm going to use the traffic jam to send some traffic through this Netropy. As I see here, this traffic jam is a traffic generating tool. It's actually running right now. Let me stop that. All right. The source port is 10.0.0.10, and it's sending data to its secondary port, which is 10.0.0.11, and it traverses through the Netropy. So I'm going to go ahead and add traffic jam port 1, and it's plugged into port 1 on the Netropy. I'm going to assign it to Wi-Fi, and his IP address is 10.0.0.10. Now, if I wanted to, I could actually do an entire subnet, but in this case, I'm just doing a single IP. I'm going to go ahead and create that, and now we can see a visual rendering of traffic jam port 1 is connected to Wi-Fi port 1. I know Zoom meetings sometimes doesn't show, but there's a line connecting this dot to that dot. Sometimes Zoom meeting doesn't show it. So if you don't see it, there's an actual line connecting these. So let me go ahead and add the other endpoint, which is traffic jam point port 2. And he's plugged into port 2 of the Netropy. He's going to go to Wi-Fi, and his IP address was 10.0.0.11. Create that. And let's go ahead and start a test. I might need to refresh this. All right, let's stop this guy. There we go. All right, so I can see on my traffic jam, I'm sending about a 1 gig throughput. So if I look at my bypass, I should be able to see this traffic come through. Let's see it over here. Oh, I put the wrong IP address in. I'm running the wrong test. Let's start the right. There we go. Sorry about that. There we go. So now we can see the traffic running through here. So what I'm going to do now is I'm going to turn on emulation, and we'll watch the performance of my traffic jam go from 1 gig, and we should get below 5.5 megabits throughput. So I'm going to go ahead and turn on emulation, and we can see that my performance has gone way down. And we can see here, we're getting around 5.5 megabits in one direction, and then in the opposite direction, we're only getting 360K, because we're not sending any data over this on the return path. These are just acknowledgements. Okay, let's do some more fun. I have other things connected to the Netropy, 2 Linux boxes. I'm going to put them on the New York to London path. And let's go ahead and get that done. I'm going to bring in a terminal window. And let's go to Linux 1. All right, so let me take a look at my IP addressing, 20.0.0.112. So this computer is plugged into port 1 on the Netropy. So let me ping to the opposite side, which is 20.0.0.11, which is my secondary Linux box. So I'm going to go ahead and create an endpoint called Linux 1. It's plugged into port 1. And we'll put him on the New York City to London path, and his IP address is 20.0.0.112. Let's turn off my emulation for now. So I'm going to create, Linux -1. So now we see Linux 1 is plugged in here. And let me log into Linux 2. Double check my IP address, 20.0.0.11. So let's create Linux 2. Plug it into port 2. And his IP address is 20.0.0.111. So I'm going to create that. So right now we have emulation turned off, but as I turn it on, I'll have 2 tests running. I'll have the traffic jam running over Wi-Fi, and then I'll have Linux 1 and Linux 2 taking on the conditions of the New York City to London path that I created. So let's go ahead and I'm going to minimize this screen a little bit, pull up my ping that I have running here. So as soon as I turn on emulation, watch my ping down here. There we go. We can see we'll be between 30 and 120 milliseconds of jitter. So let's do some on-the-fly changes, which is always fun. I'm going to come in and I'm going to actually do some path changes or network changes on the fly as we watch this ping time down here. So maybe I want to do a network outage, do a periodic. So every we'll say every 10 seconds, give me a 3-second outage. And I'll go ahead and apply that change. And we should see, yeah. There we go. We see it hanging. And now it comes back. I'll go ahead and turn that off. And then just for fun, I always like to show people that they can see duplicate packets with a ping. So I'm going to give a 70% probability of duplicate packets, apply my change, and now we start seeing duplicate packets coming through here. Turning it off. Now, let's kind of show you why this topology view is good. I can have, let's say I have multiple machines going from New York to London and I want to emulate that. So maybe I have Linux 3 and he's port 1 and maybe his IP address is 13 and he's on port 1. So I can create that, and now we can see there's a 2-to-1 endpoint. So there's 2 plugged into port 1 and 1 Linux on port 2. So you can have many to 1 or many to many. So I'll do Linux-4, plug him into port 2, and maybe he's .14. There we go. So now we have many to many, and we can keep going. And as you see, it adjusts as you add your endpoints. This allows you to see exactly what's going on the emulator, instead of before you had to go and look at your packet classifiers and see what else is going on. You had to kind of do some snooping around to see exactly what's happening. Now you can open up, you can see which endpoints are plugged in where, and you see, and you know, okay, my Linux 1, 3, and 5 are plugged into port 1 on the New York City to London path, and then Linux 2 and 4 are plugged into port 2 of the same path. And there's, oh, my traffic jam is on Wi-Fi. So now I'm going to show you the really cool stuff. I'm going to show you the API. So I'm just going to run some API scripts. Just for fun. So as I was saying, everything is automatable. So let's do a, what I'm going to do is run a Python script that deletes everything and turns off emulation. So it's authenticating, and then it cleans everything up. And as we see, everything just disappeared. Now let's go look at my traffic jam. I can see here my emulation got turned off and I went back to full speed. Now I'm going to create an environment that I had created before that resets up the traffic jam. So let me remember the name of that script. Traffic jam builds. So this is going to recreate a network for the traffic jam. So as we see, traffic jam port 1 is plugged into traffic jam 100 millisecond 500 megabit line. And then traffic jam port 2 is plugged into port 2 of this path, and then emulation was turned on. So if I go back and look, I can see this is where emulation turned on. Now we're getting less than 200 megabits throughput because I have 100 milliseconds of delay and it's only a 500 megabit line. Let's see what else is on here. Yeah, so it's very simple. And let me recreate my ping again. Let's see, what was the name of that script? Lab build. And this is going to recreate the Linux 1 and 2 lab with 70 milliseconds, 100 megabits. So now if I look at my ping that was running over here, I see I'm at 70 milliseconds. Okay, great. I see I got some questions. Okay, so yes, Norman. Norman asked, the traffic jam is a traffic generator application which is running on the clients which are connected to ports on the Netropy appliance, N61. The traffic jam is actually a physical device that we sell. It's just a very simple traffic generating tool. It's its own appliance, and it has 3 ports, a management port where I log in here, and then a port 1 for sending or receiving data, and then a port 2 for sending and receiving data. So what I've done is I've plugged in port 1 of my traffic jam into port 1 of my Netropy, and then port 2 is plugged into port 2 of my Netropy, so I'm able to send and receive traffic to the same device. I hope that answers the question. And now I got another question. In this new Netropy version, can we still upload recorded PCAP file to emulate side traffic stream? The answer is yes, you can. Everything that 3.0 had, we have as well. Let me go into the administration. So here we have our recordings. I'm actually running a alpha version or a QA version of 6.0, so we don't have the PCAP loaded here, but it's going to be there, trust me. I think it's going to be released in the next couple weeks, but right now we can do our recording playbacks as well as our PCAP playback. All right. Are there any other questions? All right. So I'll kind of gloss over these other things. This is a view detailed statistics. It's pretty easy to understand what it does. You can come in and you can see your statistics on this graph. It's very similar to what we had in 3.0, but up here we can actually see some of our data running through. We have our rate, frames, bytes, drops, loss drops, reorders, duplicates, and corruptions. And then we have our transfer rate, frames, transfer bytes, queue length. So we have everything listed right here. That's in one direction. That's from port 1 to port 2, and this is port 2 to port 1. So you can get really granular and detailed on this. So manage endpoint rules. So some people ask me, okay, well, what if traffic jam port 1 is going to go to Linux 2? How would you configure that? So let me just add a new path. I'll create a satellite path here. Under satellite, we have a bunch of different templates. We have satellite good, bad, low Earth orbit, mid Earth orbit, geosynchronous Earth orbit. The most common is probably GEO right now, but according to Elon Musk, we will all be using LEO in the next 15, 20 years. So I'll do a satellite bad connection. So I'm going to create paths. So now let's say if I want to send traffic from traffic jam port 1 to Linux 2, I can't just simply come in here and add a new endpoint. I want to make sure I can get that traffic siphoned off and pointed to this SATCOM path. So I'll manage endpoint rules. So I'll select an endpoint. We'll say traffic jam port 1, and he's going to go to Linux 2, and I'll assign that to SATCOM. I'll go ahead and add that, apply my change. Now, if I look at my topology, I see traffic jam port 1 is connected to Linux 2 over here. Hopefully that made sense. So you can get really detailed with your endpoint rules in here. All right. So Philippe asks, will all the new features be available in Linktree products? No, unfortunately they won't be. The 4.0 is only for Netropy, and the Linktree models will stay the same. All right, so any other questions? Okay, so if any of you have any questions, feel free to email myself, cade@apposite-tech.com. You can also just email support@appositech.com, and we can answer those. Looks like I got a couple more. Okay, great. I got a couple more questions. So Frederick answers, could an endpoint define an entire subnet? The answer is yes. I will do that. Let's just say IoT devices, phones, plugged into port 1, and I can say this is 172.16.0.0/24. I'll assign that to Apposite Lab. I'll create that, and now I can see my IoT device phones are here with the entire subnet. We can also do VLANs as well. So maybe, you know, we have we'll do remote office, and maybe that's on port 2 of the same, and maybe that's VLAN 2000. So that's everything in VLAN 2000 will be put on the Apposite Lab. I can create that endpoint, and now we see my remote office here is on VLAN 2000. Nate asks, can you tell us where the API RESTful documentation can be found? Sure, the RESTful documentation can be found over here. We have an API guide. This is kind of like a quick start or a quick reference guide. This shows you, it kind of walks you through the most common things in the API. For example, how to create the cookie to log in. All examples here are in curl. And then it teaches you how to gather Netropy information. Then it's going to go on to gathering a path information, creating a path with jitter and bandwidth throttling, deleting a path. So this is, you know, then goes into endpoints and then all the way into statistics gathering here as well. There's also another guide, which if some of you are familiar, it's using Swagger. And this can kind of teach you, this has every command listed possible. So maybe I want to find out how to, you know, gather path information. Let me find, go down to path. All right, so, oh, I don't want to do a post. I want to do a get. So let's do, so this says Swagger. So what I can do here is I can try it out. I'm gonna gather statistics for engine 1. I'm gonna execute it. It actually runs it and gives you an example of what the curl would look like. I need to actually find my path information on this, so I can do that real quick just for fun. Go back over here. First thing I need to do is log in. I'm doing this in Bash. Now I'll do a get of all paths. And this should work. There we go. Now I can see my different paths in JSON format. So first thing I want to do, this is showing me all my paths. So here we see my SATCOM path, and its rate is 5 megabits in one direction. And let's see what else we got. 3 megabits in the opposite direction. So some of this says false, that it's not turned on. And then we can see we have uniform delay anywhere from 450 milliseconds to 1000. So that one's actually kind of hard to read. Let's do an easier one and just gather the information on it here. Hopefully this is making sense to, so this is actually ID1. So that should be easy to gather information on. There we go. All right, so now this is only showing the very first path, which is called Apposite Lab, 700 milliseconds. And we can see here that it is currently set to 100 megabits in one direction, 100 megabits in the other direction. And we have 35 millisecond latency in another direction. All right, so Idzik asks, is 4.0 a software package I can use on your Netropy device, or I need a hardware upgrade? It is a software upgrade as long as you are in a N61 or a 10G. There are some old hardware where it doesn't run, but those are pretty old devices out there. Like if you have an N60, you can't upgrade that, but an N61 you could answer. All right. Frederick asks, same question for QoS. On the old version, it was possible to take a path based on TOS. So anything 3.0 can do, 4.0 can do as well. It just, you know, we have just a different skin on it. And some other things I actually want to stress is you can now do 30 paths. Before on the Flash version, you were limited to only doing 15 paths. So another disclaimer is I am using a beta version of my software on my N61 here. So it's not showing everything such as the PCAP replay and other stuff like that. But everything 3.0 can do, 4.0 will be able to do. If anyone else has any questions, feel free to email me, cade@appositetech.com, or send it into support@appositetech.com. And then with that being said, thank you for joining. We hope you enjoy the new interface. We're really pleased with it. Being on HTML5 allows us to get on many different types of web browsers. And we're really think this is a great design, and it's easy to see what's happening on your Netropy. So feel free to give me any more questions, and I hope to talk to you guys soon. Thanks for joining the webinar.